Hello, my name is Simil Abid and I'm from Creative Computing Year 2 and this is my presentation on Internet of Things. First up, what is Internet of Things? The Internet of Things refers to a network of physical objects that are connected to the Internet and equipped with sensors, software, and communication technologies. These devices can collect and exchange data automatically without requiring constant human interaction. IoT expands internet connectivity beyond traditional devices such as computers and smartphones to include everyday objects like smartphone watches, home appliances, vehicles, and industrial machines. By allowing these devices to communicate and share information, IoT systems can respond to environmental conditions and make processes more efficient and automated. How IoT works. IoT systems function through a multi-layered architecture that allows devices to sense their environment, transmit data, analyze information, and perform automated actions. While the basic model includes sensors, connectivity, processing, and output, real-world IoT systems often involve several interconnected layers. First, sensors and smart devices collect data from the physical environment. These sensors may measure variables such as temperature, movement, location, humidity, heart rate, or air quality. Devices like smart thermostats, wearable fitness trackers, industrial machines, and vehicle sensors continuously generate large amounts of data. Next, the collected data is transmitted through communication networks. IoT devices use different connectivity technologies such as Wi-Fi, Bluetooth, cellular networks, or 5G. In many systems, an IoT gateway acts as an intermediary that aggregates data from multiple sensors before sending it to cloud platforms. After transmission, the data is stored and processed in cloud computing environments or edge computing systems. Cloud platforms provide large-scale storage and computational power that allows organizations to analyze vast amounts of IoT data. In some cases, processing occurs close to the device using edge computing, which reduces latency and enables faster responses. The analyzed data is then interpreted using data analytics or machine learning algorithms. These systems detect patterns, identify anomalies, and generate insights from the collected information. For example, a smart energy system may analyze electricity usage patterns to optimize energy consumption. Finally, the system produces an output or action. This could involve sending information to a user through dashboards, mobile apps, or alerts. Alternatively, the system may automatically perform actions such as adjusting home temperature, activating security systems, or controlling industrial machinery. This entire process allows IoT systems to monitor environments and respond in real time. Next, we have the brief history of IoT. The development of IoT has occurred gradually over several decades as computing, network, and sensor technologies have advanced. 1980s, early connected devices. Some of the earliest examples of connected devices appeared in the 1980s. One well-known example was a network-connected Coca-Cola vending machine at a university that allowed users to check drink availability remotely through the internet. 1990s, emergence of connected systems. During the 1990s, technologies such as radio frequency identification began to be used in supply chain management. These technologies allowed physical objects to be tracked and identified digitally. 1999, the term Internet of Things introduced. The term Internet of Things was first coined by Kevin Ashton in 1999 while working on supply chain innovations at MIT's Auto ID Center. Ashton described a system where objects could communicate through sensors and networks without direct human involvement. The 2000s, growth of wireless networks and sensors. Advances in wireless communication and microelectronics made it possible to build smaller, cheaper sensors that could connect to networks. This enabled the development of early smart home devices and industrial monitoring systems. 2010s, rapid expansion of IoT. The widespread adoption of smartphones, cloud computing platforms, and high-speed internet significantly accelerated IoT development. Many industries began implementing IoT technologies for automation monitoring and data-driven decision-making. 2020s, integration with AI and machine learning. Today, IoT systems are increasingly integrated with artificial intelligence and machine learning technologies. These systems allow devices not only to collect data, but also to analyze it intelligently and make autonomous decisions. IoT now plays a key role in smart cities, autonomous vehicles, digital healthcare, and sustainable energy systems. Next, we have the key IoT applications. Let's discuss them. First, we have smart homes. Smart homes are one of the most common applications of IoT technology. In a smart home environment, connected devices such as thermostats, lighting systems, security cameras, and voice assistants communicate with each other through internet networks. These systems allow homeowners to control devices remotely using smartphones or voice commands. Smart home technology can improve energy efficiency, convenience, and security by automating everyday tasks. However, because these systems collect large amounts of personal data, they also raise concerns about privacy and cybersecurity risks. Next, we have driverless cars and connected vehicles. Connected vehicles and driverless cars rely heavily on IoT sensors to monitor their surroundings and communicate with other systems. These vehicles use technologies such as cameras, radar, LiDAR sensors, and GPS to collect real-time environmental data. Through vehicle-to-vehicle and vehicle-to-infrastructure communication, cars can share information about traffic conditions, road hazards, and navigation routes. This connectivity helps improve road safety and traffic efficiency while supporting the development of autonomous driving technologies. Then we have healthcare and wearable devices. IoT technologies are increasingly used in healthcare through wearable devices and remote monitoring systems. Devices such as fitness trackers and smartwatches can continuously monitor psychological data, including heart rate, physical activity, and sleep patterns. These devices allow healthcare providers to track patients remotely and detect potential heart problems earlier. As a result, IoT can improve patient care, reduce hospital visits, and enable more personalized healthcare services. Next, we have smart cities. Smart cities use IoT technologies to improve urban infrastructure and services. Sensors installed throughout cities collect data related to traffic flow, pollution levels, energy usage, and waste management. This data can help city authorities optimize public services and respond quickly to environmental or infrastructure issues. Smart city systems aim to improve efficiency, sustainability, and quality of life for urban populations. Then we have agriculture, smart farming. IoT is transforming agriculture by enabling precision farming techniques. Sensors placed in fields can monitor soil moisture, temperature, and crop conditions. Farmers can use this information to optimize irrigation, fertilization, and harvesting processes. This improves agricultural productivity while reducing water usage and environmental impact. IoT-based farming solutions are becoming increasingly important as global food demand continues to grow. Then we have industrial IoT. Industrial IoT refers to the use of connected sensors and devices within manufacturing and industrial environments. These technologies allow companies to monitor machines, predict equipment failures, and optimize production processes. Predictive maintenance systems can detect potential issues before equipment breaks down, reducing downtime and operational costs. Industrial IoT also improves supply chain management and production efficiency. Then we have the IoT plus machine learning. Why machine learning is important for IoT. IoT systems generate enormous amounts of data from sensors and collected devices. Without advanced analysis tools, this data would be difficult to interpret. Machine learning allows systems to analyze large data sets, identify patterns, and make predictions automatically. By combining IoT with machine learning, systems can move beyond simple automation and develop intelligent decision-making capabilities. How machine learning is used in IoT. Machine learning enhances IoT systems in several important ways. In industrial environments, predictive maintenance models can identify potential equipment failures before they occur. In smart homes, algorithms can analyze user behavior to automate lighting and heating systems. In healthcare, wearable devices can detect abnormal health patterns using data analysis. Autonomous vehicles also rely on machine learning models to interpret sensor data and make driving decisions in real time. The benefits of IoT. IoT technologies offer several benefits across many industries. They improve efficiency by automating tasks and enabling real-time monitoring of systems. IoT also helps organizations manage resources more effectively, such as energy usage in buildings or water usage in agriculture. Additionally, connected devices can enhance safety and improve quality of life through smart healthcare monitoring, safer transportation systems, and improved industrial operations. Then we have risks and challenges of IoT. Although IoT technologies provide many benefits, they also introduce significant technical, social, and ethical challenges. One of the most serious concerns is privacy. IoT devices continuously collect data about individuals and their environments. Smart home devices, wearable health monitors, and connected vehicles can gather sensitive information about personal habits, locations, and behaviors. If this data is misused or accessed by unauthorized parties, it may compromise individual privacy. Another major challenge is cybersecurity. Many IoT devices have limited computing power and weak security protections, making them vulnerable to hacking. Attackers may gain access to networks through poorly secured devices and use them to launch cyber attacks or steal data. There are also ethical and legal issues related to automated decision making. For example, in autonomous vehicles or medical monitoring systems, determining responsibility when an automated system fails can be complex. Additionally, IoT may contribute to digital inequality. Advanced connected technologies are often more accessible in developed regions with strong digital infrastructure. This can widen the technological gap between different countries and communities. Finally, societies may become increasingly dependent on automated systems. Over-reliance on automation could reduce human skills and create vulnerabilities if systems fail or experience technical disruptions. Next, we have the future of IoT. The Internet of Things is expected to have a profound impact on many aspects of modern life. As connected devices become more widespread, they will continue to transform industries, urban environments, and everyday human activities. In the future, IoT technologies will likely play a central role in the development of smart cities, where interconnected infrastructure systems manage traffic, energy usage, waste management, and environmental monitoring more efficiently. These systems can help reduce pollution, optimize transportation networks, and improve the overall quality of life in urban areas. IoT will also significantly influence the healthcare systems. Continuous health monitoring through wearable devices and remote sensors could enable earlier detection of medical conditions and more personalized treatment plans. This may reduce the need for hospital visits and improve patient outcomes. In the industrial sector, IoT technologies will support the development of fully automated and data-driven manufacturing systems. Smart factories will use predictive maintenance and intelligent production processes to increase efficiency and reduce operational costs. Furthermore, IoT may contribute to environmental sustainability. Smart energy systems, connected transportation networks, and precision agriculture technologies can help reduce resource waste and improve environmental management. However, the future success of IoT depends on addressing important challenges such as cybersecurity, privacy protection, and ethical use of data. Governments, organizations, and technology developers will need to establish strong regulations and standards to ensure that IoT technologies are used responsibly and safely. Lastly, the Internet of Things represents a shift toward a more connected and automated world, and when combined with machine learning, it has the potential to solve significant human problems while also introducing new social, ethical, and technological challenges. Next, I have diagrams to understand IoT better. This is the IoT system flowchart. This flowchart shows the basic architecture of an Internet of Things system and how data moves through different stages. IoT devices and sensor first collect real-world data such as temperature, motion, location, or health information. The data is transmitted through a network or IoT gateway, which connects physical devices to Internet infrastructure. Once the data reaches cloud storage, it can be processed and analyzed using data analytics tools. The processed information is then displayed on user dashboards or mobile applications, allowing users to monitor systems and make decisions in real time. Next, I have the IoT plus machine learning data flow. This diagram illustrates how machine learning enhances the functionality of Internet of Things systems. IoT devices continuously collect large amounts of raw data from sensors embedded in physical environments. The data is transmitted through networks and stored in cloud platforms where it can be accessed and analyzed. Machine learning models analyze this data to identify patterns, detect anomalies, and make predictions. Based on these predictions, the system can trigger automated actions, send alerts and notifications, or provide insights through user dashboards. Next, I have Smart Home IoT system. This diagram represents a smart home ecosystem powered by Internet of Things technology. Multiple connected devices such as smart lights, thermostats, security cameras, and door locks communicate through a central system. Cloud services store and process data collected from these devices, enabling remote control and automation. Users interact with the system through mobile applications or voice assistants, such as smart speakers. The system allows homeowners to automate daily tasks, monitor security, and control home environments from anywhere. And then I have the driverless cars IT system. This case diagram illustrates how a self-driving taxi service operates using Internet of Things technologies. Passengers interact with the system through a mobile application where they can write a book, select pickup and drop-off locations, and complete payments. The self-driving vehicles uses IoT sensors and connected systems to navigate roads, detect obstacles, and transport passengers safely. Fleet operators can monitor vehicles in real time, manage routes, and ensure efficient operation of the taxi service. Maintenance technicians receive system alerts and vehicle diagnostics, allowing them to detect technical issues and perform repairs when necessary. And these are the references. And this was my presentation on Internet of Things. Thank you.